Welcome to the deep dive. In a world just brimming with information and endless tasks, we're all constantly juggling. And simple automation, well, it just isn't cutting it anymore for those really complex multi step workflows, the ones that always seem to resist our best efforts. So today, we're diving into a really fascinating solution that's rapidly gaining traction: agents. These aren't just another tech buzzword. Our source material, it's a practical guide, actually, distilling insights from loads of real-world customer deployments. It shows us how agents represent a pretty significant leap in how AI can genuinely help us. Our mission for you, our curious listener, is simple. By the end of this deep dive, you'll have the foundational knowledge you need to confidently understand what agents are, when you should use them, and how they're built. Basically giving you a shortcut to being well-informed. Let's jump in.
Okay, let's unpack this then. When we think AI automation, many of us, we immediately picture chatbots answering questions, or maybe simple systems doing one-off tasks. But agents, as our source material clearly outlines, they're kind of a whole new category.
A significant step beyond that. So, what exactly is an agent, and what makes it truly different from, say, a very smart chatbot?
Well, what's fascinating here is that while, yeah, conventional software helps users streamline workflows, agents take it a step further. They are systems specifically designed to independently accomplish entire workflows on your behalf. They operate with a really high degree of independence. The core difference really is an agent isn't just responding to you, it's genuinely acting for you.
Acting for you. Okay.
Yeah, and more concretely, an agent, it has two core characteristics. First, it leverages a large language model, an LLM, right, to manage the entire workflow execution and make decisions. So this means it can recognize when a workflow is complete, proactively correct its own actions if something goes a bit wrong, or even, halt execution and transfer control back to you if it hits a wall.
Okay. So it's got some self-awareness there.
Exactly. And second, it accesses various tools to interact with external systems. These tools let it gather context, like looking up information, and take actions like sending an email or updating a database. Crucially, it dynamically selects the right tools within clearly defined guardrails we'll talk about later.
Right, right. That concept of a full workflow seems key, doesn't it? It's not just one action. Our source gives some great examples, like resolving a customer service issue, which could involve, you know, tons of steps and decisions, or booking a restaurant reservation, maybe committing a code change, or generating a complex report. So think of it this way, listeners. Instead of just a smart assistant that gives you information, an agent is an assistant that actually acts on that information to get things done for you. It sees the process through, start to finish.
Precisely. It completes the loop.
Now, here's where it gets, well, really interesting for me. If agents are so powerful, should we just use them for everything? Our guide makes it clear they're uniquely suited for specific types of workflows, particularly where those traditional deterministic and rule-based approaches kind of fall short.
Yeah.
The system's relying on strict preset rules instead of adaptive reasoning. So when is an agent truly the right tool for the job? What kind of problems are we talking about?
That's a crucial consideration, identifying that sweet spot for agent deployment. The source uses this really compelling analogy of payment fraud analysis. Imagine a traditional rules engine. It's basically a checklist, right? Flagging transactions based on explicit criteria, if this, then that.
Yeah, very rigid.
Very rigid. But an LLM agent, in contrast, functions more like a seasoned investigator. It evaluates context, considers subtle patterns. It can identify suspicious activity even when no clear-cut rules are explicitly violated. That nuanced reasoning capability, that's precisely what allows agents to manage complex, ambiguous situations effectively.
Okay, that makes sense. It's less black and white.
Exactly. What truly clicked for me there was understanding it's about bringing almost like intuitive reasoning to problems that were previously too fuzzy for machines. That's a pretty profound shift.
Yeah, absolutely.
So when you're evaluating where agents add the most value, you should prioritize workflows that have really resisted automation, especially where traditional methods just hit friction. The guide highlights three main types of workflows to prioritize. First, complex decision-making.
Okay.
These involve nuanced judgment, exceptions, or decisions that really depend on context, like approving a refund in customer service where every case might be slightly different.
Right. No simple rule applies to all.
Exactly. Second, difficult to maintain rules. Think of systems that have just become unwieldy, massive, intricate rule sets, making updates costly or super error-prone. A great example is performing vendor security reviews, where the rules and threats evolve constantly.
Oh, I can picture that spreadsheet nightmare.
Yeah. I could almost picture the developers breathing a sigh of relief, thinking finally an escape from that monster spreadsheet of rules I've been maintaining for years.
Huh, probably.
And third, heavy reliance on unstructured data. These are scenarios involving interpreting natural language, extracting meaning from various documents, maybe interacting conversationally, processing a home insurance claim, for instance, dealing with incident reports, photos, verbal descriptions. That's a perfect fit.
That's a really clear breakdown. And it's important to remember the caution here too, right? If a use case doesn't clearly meet these criteria,
Mm-hmm.
a traditional deterministic solution might still be sufficient, maybe even simpler. You don't always need the sledgehammer.
Absolutely. Choose the right tool.
Yeah. So bottom line for you listeners, if you've got a task that's always been too complicated or too messy for simple automation, that's your cue. That's when you should consider an agent. Okay, so we know what an agent is, we know when we might need one, but how do we actually build one? Our guide outlines 3 core components, the very foundation. What are they?
Right. At its most fundamental level, an agent consists of 3 core components. First, the model. That's the large language model itself. The brain, powering the agent's reasoning and decision-making.
Okay, the LLM.
Second, the tools. These are the external functions or APIs the agent can use to actually take action or get information.
The hands and eyes, sort of.
Sort of, yeah. And third, the instructions. These are the explicit guidelines and, importantly, guardrails defining how the agent behaves, what its job is.
Got it. Model, tools, instructions. Let's dive into selecting your models first. My initial thought is, well, surely we just use the biggest, smartest, most powerful model for everything. But that feels like it could get really expensive really fast. Is there a more strategic way?
Oh, absolutely. It's a common misconception. Different models have varying strengths and, crucially, trade-offs related to task complexity, latency, and cost. It's really important to understand that not every task needs the smartest model available. A simpler task, maybe like basic retrieval or classifying intent, might be handled perfectly well by a smaller, faster model.
Cheaper too, presumably.
Cheaper, faster, exactly. Whereas harder tasks, like, say, deciding whether to approve a complex refund, will likely benefit from a more capable, perhaps larger model. So a practical strategy the guide suggests is to prototype with the most capable model you can access. Establish your performance baseline. See what good looks like.
Right?
Then you can try swapping in smaller, potentially cheaper or faster models to see if they still achieve acceptable results. This way you optimize for cost and latency without prematurely limiting the agent's abilities right at the start.
Build strong, then optimize. That's great advice. Okay, and those hands you mentioned, the tools, they're clearly next. They allow the agent to interact with the world outside its core LLM, yeah.
Exactly. Tools are what extend your agent's capabilities. They typically use APIs from underlying applications or systems. And interestingly, even for legacy systems that might not have APIs, agents can sometimes rely on computer use models to interact directly through web and application UIs, pretty much just as a human would. Click here, type this.
Wow, okay, so it can even handle older systems.
Potentially, yes. The guide broadly categorizes the tools agents need into 3 types. First, data tools. These enable agents to retrieve context and information. Think querying databases, reading PDFs, searching the web.
Reading the facts.
Yep. Second, action tools. These allow agents to interact with systems to actually take actions. Things like sending emails, sending texts, updating a CRM record, maybe handing off a customer service ticket to a human agent.
Making things happen.
Making things happen. And third, this was really interesting, orchestration tools. This is where agents themselves can serve as tools for other agents.
Okay.
Think of having a specialized refund agent or maybe a research agent that another, more general agent could call upon when needed.
Agents using other agents, that is a powerful concept, but doesn't that introduce like a whole new layer of complexity? How do you manage that effectively?
It definitely can. But when it's structured correctly, it's incredibly efficient. It really highlights how interconnected these systems can become. Which brings us nicely to the third pillar, configuring instructions. This is where we tell the agent its job, right? How to behave, its purpose, the rules of the road.
Yes, exactly. And high-quality instructions are, well, they're especially critical for agents. Clear instructions reduce ambiguity, which significantly improves an agent's decision-making. That leads to smoother workflow execution and, crucially, fewer errors.
Makes sense. Garbage in, garbage out, even for AI.
Pretty much. The source outlines several best practices here. First, use existing documents. Convert your existing standard operating procedures, support scripts, policy documents, whatever you have, into LLM-friendly routines. For instance, in customer service, you could map routines directly to articles in your knowledge base.
Leverage what you already have. Smart.
Definitely. It's also important to prompt agents to break down tasks, give them smaller, clear steps, especially from dense resources, to minimize ambiguity. Don't just throw the whole manual at it.
Chunk it down. Chunk it down. You also need to define clear actions for every single step in a routine. Ensure it corresponds to a specific action or output. You might even need to specify the exact wording for user-facing messages.
Be really specific.
Very specific. And finally, maybe most importantly for real-world use, capture edge cases. Real interactions are messy, right?
Oh, yeah.
So a robust routine anticipates common variations, like maybe the user provides incomplete information and it includes conditional steps on exactly how to handle those situations.
Planning for when things don't go perfectly.
You have to.
That's a fantastic framework for instructing these systems. So ultimately, the takeaway from these three pillars, the model, the tools, and the instructions, it really boils down to clarity, doesn't it? A focused model, precise tools, and unambiguous instructions seem like the secret sauce for building agents that actually deliver value.
That's a great way to put it. Clarity is key.
Okay, so once we have our agents, let's say, DNA sorted the model, tools, instructions, how do we make it all work together effectively? Our guide talks about orchestration patterns. Should we be aiming for like one giant super agent that does everything? Or is it more about building a team of specialized agents?
Yeah, it's rarely about building one super agent to rule them all, especially not from day one. The advice here is definitely an incremental approach. Don't immediately try to build a fully autonomous agent with some overly complex architecture right out of the gate.
Start simpler.
Start simpler. Orchestration patterns generally fall into two main categories. Single agent systems, where basically one model equipped with tools runs a workflow, often in a loop, and multi-agent systems, where the workflow execution is distributed across multiple coordinated agents. With single agent systems, one agent can often handle many tasks just by incrementally adding more tools. This keeps the complexity manageable, at least initially, and it simplifies evaluation and maintenance. Each new tool expands its capabilities without forcing you prematurely into the complexity of orchestrating multiple agents.
Right.
The concept of a run is central here. It's typically implemented as a loop that lets the agent operate until some exit condition is met that could be reaching a final output, encountering an error it can't resolve, or maybe hitting a maximum number of turns or steps.
Okay.
And for managing complexity within that single agent, using prompt templates is a really effective strategy. Instead of juggling loads of individual prompts for every variation, you use a single flexible base prompt that accepts policy variables. It adapts to various contexts and drastically simplifies maintenance.
Ah, like a fill-in-the-blanks approach for the prompt.
Sort of, yeah. It's much more scalable.
That makes perfect sense for starting out. But when do we know it's time to graduate? When do we move from a single agent to a multi-agent system? What are the telltale signs that your single agent is kind of reaching its limits?
That's a really important question, knowing when to scale up the architecture. The general recommendation is definitely to maximize a single agent's capabilities first. Because more agents, while they can provide an intuitive separation of concepts, they do introduce additional complexity and overhead. You've got more moving parts.
Right, more to manage.
But for many complex workflows, splitting up the prompts and the tools across multiple agents can lead to improved performance and better scalability in the long run. The practical guidelines for deciding when to split include, first, complex logic. If your prompts start containing lots and lots of conditional statements like, if this, then that, but if this other thing, do this instead. Or if your prompt templates themselves become really difficult to scale and manage, that's a good sign. It's time to divide each logical segment across separate, specialized agents.
Okay, when the if statements pile up too high.
Exactly. Second trigger is tool overload. And the issue here isn't solely the number of tools, interestingly. It's often their similarity or overlap. Some implementations, the guide notes, successfully manage more than 15 well-defined, very distinct tools, while others might struggle with fewer than 10 tools if those tools are too similar or overlap in function, confusing the agent about which one to pick.
Ah, so clarity of the tools matters more than just the raw count.
Precisely. So if improving tool clarity, maybe better descriptions, more distinct functions, doesn't resolve the performance issues, then multiple agents are likely needed.
Got it.
So once you're ready for multi-agent systems, the guide highlights two broadly applicable patterns that cover many use cases. The first is the manager pattern. Here, agents act as tools for another agent. You have a central manager agent that coordinates multiple specialized worker agents via tool calls. Each subordinate agent handles a specific task or domain.
Like a team lead.
It's exactly like a team lead. The manager intelligently delegates tasks and then synthesizes the results from the different workers into one cohesive interaction for the user. This ensures a smooth, unified user experience. This pattern is ideal when you want one agent to control the overall workflow execution and maintain access to the user. For example, maybe a translation manager agent that delegates to specialized Spanish, French, and Italian agents and then provides a single, comprehensive translated response back.
Right, the manager pulls it all together.
Yeah. What's fascinating here is really how the manager intelligently delegates and then maintains that unified experience, even though multiple specialist agents were involved behind the scenes. The second main pattern is the decentralized pattern. This is where agents are handing off tasks to other agents.
Okay, more like passing the baton.
Exactly. In this setup, multiple agents operate more like peers. They hand off tasks to one another based on their specializations. These handoffs are typically one-way transfers, acting kind of like a tool call that pass control in the conversation state over to the next agent in the chain. This is optimal when you don't necessarily need a single agent maintaining central control or synthesizing results. For example, you might have a customer service triage agent that assesses an initial query, figures out what it's about, and then completely hands off the user and their request to, say, a dedicated order management agent.
So the first agent steps away entirely.
It steps away entirely. This raises a crucial consideration. When would you want an agent to completely step aside and let another specialized agent take the reins? It's really about letting the true expert for that specific part of the problem handle the interaction from that point onward. No need for the initial agent to stay involved.
This really is like building an effective team, isn't it? Sometimes a versatile generalist, that single agent is all you need. But for really complex, specialized projects, you might need that well-orchestrated team of experts, the multi-agent system, each with their own specific responsibilities and really clear handoff protocols.
That's a perfect analogy. Team structure matters.
Okay, this all sounds incredibly powerful, but, with great power comes great responsibility, right? How do we make sure these agents operate safely, predictably, and, frankly, within ethical boundaries? Our guide really stresses the critical role of guardrails.
Oh, absolutely. This is non-negotiable. Guardrails are an essential, and I'd emphasize layered, defense mechanism for managing risks. They're crucial. They help prevent things like data privacy issues. You definitely don't want system prompts leaking out, for example. And they also protect against reputational risks, like enforcing brand-aligned behavior from the model. You don't want your agent saying something off-brand or harmful.
Yeah, definitely not.
And it's crucial to understand, guardrails aren't a magic bullet on their own. They should always be coupled with robust authentication, authorization, strict access controls, and all the standard software security measures you'd normally employ.
Defense in depth.
Exactly. Think of them as multiple layers of protection, because a single guardrail is almost never sufficient.
Okay, so what kind of layers are we talking about? What specific types of guardrails does the guide mention?
Right, the guide details various types and gives specific examples which really help illustrate their function. For instance, we have relevance classifiers, these flag off-topic queries. So an agent designed for customer service should flag a question like, how tall is the Empire State Building, as irrelevant to its job.
Keep it focused.
Keep it focused. Then there are safety classifiers. These are designed to detect unsafe inputs, like what are often called jailbreaks or prompt injections. These are attempts by a user to trick an agent into bypassing its intended programming or maybe revealing its internal system instructions.
Ah, guarding against malicious inputs.
Exactly. We also need PII filters. PII is personally identifiable information. These filters prevent the unnecessary exposure or logging of sensitive data, like social security numbers, credit card details, etc.
Protecting user privacy.
Critical.
Oh.
And moderation tools, which flag harmful or inappropriate inputs, things like hate speech, harassment, or depiction of violence.
Basic safety and decency filters.
Yes. Furthermore, tool safeguards are really critical when agents can take actions. These involve assessing the risk level of each tool available to your agent, maybe rating it low, medium, or high risk based on factors like, is it read-only or does it write data? Is the action reversible? Does it have financial impact?
Okay, assessing the potential damage a tool could do.
Precisely. And these risk ratings can then trigger automated actions, for example, pausing for additional checks or even requiring human approval before executing a high-risk function, like, say, canceling a user's orders or making a large payment.
Right. That old adage, measure twice, cut once, really takes on a whole new meaning when an agent is deciding to, say, cancel someone's critical order.
It really does. Those guardrails are the measure twice part.
Yeah.
We also use simpler rules-based protections. These are straightforward deterministic measures, like block lists for certain words or IP addresses, maybe input length limits, or using regular expressions to filter out known patterns of bad input.
Basic but effective lines of defense.
Sometimes the simplest things work well. And finally, output validation. This ensures that the agent's responses align with brand values and integrity. It prevents outputs that could be factually incorrect, nonsensical, or somehow harm the brand's reputation.
Checking what comes out as well as what goes in.
You have to check both ends.
Okay, that's a comprehensive set of layers. But even with all these defenses, what happens if an agent still gets stuck or needs assistance? It can't be fully autonomous all the time, surely, especially early on.
You're absolutely right. It can't and shouldn't be expected to initially. Human intervention is a critical safeguard, especially early in an agent's deployment lifecycle. Having humans in the loop helps identify failures, uncover unexpected edge cases, and establish a really robust evaluation cycle that ultimately improves the agent over time. You learn from the mistakes.
Humans as the teachers and safety net.
Exactly. The guide identifies two primary triggers that typically warrant bringing a human in. First, exceeding failure thresholds. If an agent fails to understand what the customer wants after, say, 2 or 3 attempts, or if it exceeds some preset limit on retries or actions it's allowed to take in a session, it should escalate to a human operator.
Knows when to give up and ask for help.
Basically, yes. Second, high-risk actions. Sensitive, irreversible, or high-stakes actions. Things like authorizing very large refunds, making significant payments, or maybe deleting critical data. These should always trigger human oversight, at least until confidence in the agent's reliability for that specific action grows to a very, very high level through lots of testing and observation.
Makes total sense. Don't let the intern approve million-dollar transactions on day one.
Precisely.
So, okay, thinking about this whole picture, you can think of guardrails almost as the agent's conscience, right? Always watching for trouble, trying to keep it on the straight and narrow. And then human intervention is the ultimate safety net. It ensures that when the agent truly can't proceed, or when it encounters something really critical or sensitive, a skilled person is there to step in, learn from what happened, and guide it forward. And hopefully make the entire system smarter and safer for next time.
That's a great way to conceptualize it. Conscience and safety net.
So, wrapping this up, what does this all mean for you, our listener? We've just taken a pretty deep dive into how large language models are evolving from just answering questions into becoming these powerful agents capable of handling complex multi-step tasks with, frankly, impressive autonomy. It really feels like a profound shift in how we think about automation.
It really is. Agents truly mark a new era in workflow automation. We're talking about systems that can reason through ambiguity, take meaningful action across different tools and systems, and handle those tricky multi-step tasks with a whole new level of intelligence and adaptability. And as we've discussed, success really comes from building on strong foundations. You need capable models paired with well-defined tools and clear, structured instructions. It's also about choosing the right orchestration pattern for your needs, whether that's starting with a single versatile agent or designing a well-coordinated multi-agent system for more complex tasks. And crucially, layering in those critical guardrails and human intervention points for safety and reliability, especially when you move into production.
And importantly, the guide reiterates, the path to successful deployment isn't an all-or-nothing kind of endeavor. It's much more about an iterative approach. Start small, validate with real users early and often, learn and grow the agent's capabilities over time. Don't try to boil the ocean on day one.
Absolutely. That iterative process is key. Ultimately, looking at the bigger picture, agents aren't just automating isolated little tasks anymore. They're starting to automate entire complex workflows with a level of intelligence and adaptability we haven't really seen before. This could fundamentally change how organizations operate and where humans focus their efforts.
Which naturally raises a final important question for you, our curious listener, to think about after this. Now that you understand what agents are and what they can potentially do, where in your own life or work, maybe in those complex, messy, previously unautomatable corners, Where could an agent truly act on your behalf to unlock completely new levels of efficiency, insight, or maybe just free up your time? Something to ponder. Thank you so much for joining us on this deep dive today. Keep exploring this fascinating frontier.